Hi, this is Russ Dollinger from Science Glen. Let's watch Dr. Shaneka Bullins as she works with our new ionic bonding disc model to teach Jay how ionic compounds formed and the ratios. It's amazing. Let's peek in.
This and electrons are outside of the nucleus. Okay? So again, all stuff is made up of what? Word starts with an A.
Atoms.
Atoms, right? And then on the outside of every atom is?
Electrons.
Okay. So just simply understanding that sometimes atoms will gain or lose their electrons. They'll gain or lose their electrons. And the reason why they do that is because gaining and losing electrons will make them happy or makes them more stable. Okay? So some atoms will gain electrons, and when they gain electrons, they form negative ions, or we call them anions. So like anti-bullying, right? Anti-bullying.
Which is not.
Right, don't bully, right? So anion, that prefix an, anion.
So it's not an ion.
So it just means that it's a negative ion. So like anti-bullying means that you're against bullying, no bullying. So anions are negative because bullying is negative, right? So don't do it. So an anion is a negative ion. So this is an example of a negative ion because it has gained electrons. This ion has gained 1, 2, 3 electrons. This is an anion. Okay?
Okay.
What is the name of an ion that gains electrons, Jay? Anion. Yes, anion. So in this kit, there are so many different anions. We have the sulfate ion. We have the iodate ion.
That's in the hairspray?
Oh, yes. We have sulfate. Yes, absolutely. And some things like, the shampoo I use for you, it says it's sulfate free, which means that it doesn't have sulfate in it. And so on this, for this disc, right, for this ion disc, you can see how many electrons every anion has gained just by the connections. So how many electrons has this ion gained?
2.
How many has this one gained?
3.
So then, of course, you have another type of ion that loses electrons. And so this is an example of an ion that has lost 1 electron. And so ions that lose electrons are called cations. Cations.
Cation.
Yes, not cation, but cation. Okay? And so cations can lose differing amounts of electrons. Let's take a look here. This silver ion has lost 1 electron. This nickel 4 ion has lost how many electrons? Yes. And then we have the iron 2 ion that has lost
2.
Yes. So again, this every disc represents how many electrons this ion has lost.
Right, so when there's a plus and it shows a certain amount of pluses on here, that means the pluses that they lost, and then when it's negatives on here, the negative signs on here, that means that's how many negatives they gained.
Negative
electrons?
Electrons, yes. So this disc where it's positive, it means that this ion has
2 positives.
Has lost
2 positives.
2 electrons. So let's make sure we got this one right. So again, the 2 positives on this disc means that this ion has lost
2 electrons.
And then the 2 negatives on this ion means that this ion has gained
2 ions.
2 electrons. It's the same exact idea, right? So again, ions are formed when atoms gain or lose electrons only. So again, 2 electrons have been lost, 2 electrons have been gained. And so, opposites attract, right?
Right.
And so if I have positive charge and negative charge in the same amount, positive 2 and negative 2 makes 0. They cancel out. It's called canceling out.
Right.
So,
but if you have positive and negative, it goes together, right?
Yeah, they're attracted to each other and they cancel to 0.
But
so plus 1 and minus 1 makes 0. Plus 2 minus 2 makes 0. Plus 3 minus 3 makes 0. Plus 4 minus 4 makes 0.
So basically, if they have partners, it makes 0.
Exactly. If they have a partnered proton and electron, it makes 0. Now, ions, the partnership gets messed up. Because if iron loses 2 electrons, then now it's no longer neutral. Okay? Everything doesn't cancel. But it wants to cancel. Right? So even though it has lost electrons or sulfate has gained electrons, they still want to cancel to 0. So what they do is they find a partner ion. So a cation will find an anion partner, and they're still trying to get back together to go back to zero. Because now this one is +2, it's not 0. This one is -2, it's not 0. So they're like, oh man, I need to find a partner that's gonna help me cancel again.
Right.
Okay? So looking at these pieces, Jay, what do you think could happen to help the cation and the anion get back to 0? So again, this cation has +1, and it's like, I want to go back to 0.
So maybe if you...
What do you think?
Maybe...
Try with the pieces.
So,
what have you just done? Tell me why you did this.
because this one has 3. This one has 3.
Talk a little bit louder.
Okay, so...
Why did you do... So this is iodate, and how many electrons has it gained? How many electrons has it gained?
1.
And then this is silver. How many electrons has it lost?
1.
So you put them together, right?
Yeah.
Put them together. And what happens?
They come together. Become
So
partners.
they become partners. So now we have a cation partner and an anion partner. And so now iodate, who gained an electron, goes with silver that lost an electron because they're oppositely charged and they're attracted to each other, right? They're attracted to each other like a magnet. And now their charge has gone back to 0. The goal of putting together cation and anion partners is to make the charge go back to 0.
Right.
And this is called an ionic bond. They're attracted to each other because they're oppositely charged. Opposites attract. The positive part is attracted to the negative part. And they come together. They're attracted to one another to try to cancel the charge back to 0 again.
Yes.
All right. So now I have another cation. This is the iron 2 cation. And I have the sulfate -2 anion. What could we do? We want to get that charge back to 0.
Right, so...
And I want to give you some insider information. I know that the charge of my cation and anion partnership is 0, and it's gone back to canceling charges when everything is covered. So everything has to be covered. So like if that's still uncovered, then we haven't made all the partnerships. Try it again. Try to turn it this way. Oh. So now we have the +2 and the -2 that have canceled to what?
To 0?
Yes. And this is an ionic compound. And so the way we would name this ionic compound is this would be called iron 2 sulfate. Because these two, the cation and anion partnership came together, right, to cancel charge to 0. So because this one is +2, iron 2 is +2, and sulfate is -2, +2 and -2 make 0. The goal is always to make 0. All right, I'm gonna give you a challenging one. I'm gonna give you a little challenge. So we'll stick with iron 2, okay? I have iron 2, and then I have iron 2, and I have iron 2, which is my cation, and I have hydroxide, which is my anion. Let's see if we can cancel their charges.
Make it to 0?
Yes, let's see if we can make it to 0.
These are right.
Why would you use the second one? No. Tell me your thoughts. Why would you use the second one? I'm not telling you that you're doing it wrong. I would just like to know what you're thinking.
Because this one it doesn't have another one. Because you told me that all of it has to be covered, right?
Yes, correct.
So I would get this one and put it right here because it'll make it 0.
Let's try. Let's see if that works. Okay. So if I have iron, which was +2, and then hydroxide, how many is this one? How many pieces do we have sticking out?
1.
-1. And then this one is also
-1.
so -1 and -1 equals
0.
-2. 2. So we have +2 from iron, and then -2 from the 2 hydroxides.
So that would make it equal 0. So what? So like what? How am I supposed to have this as a mate?
Can you use a bigger voice? Because remember he's recording the video.
Okay. Okay. So this is a 2 plus, right?
Yes, 2 plus.
And then this is a 3 minus.
Correct.
That wouldn't even equal 0.
It doesn't. So what we do is when right now you have extra. You have a -1 left over. So you need more positive. But calcium only comes as +2.
Right.
So let's add another calcium. And now what happens?
And then I have another one that doesn't have something to cover it.
Okay.
But then I added another one, and
what is this
2
one
left? Oh, there's 3. So it's a 3 negative.
You have 2 minus that's still hanging out, right?
2 that's still left, right? So I will need another. So now I have none now I have none that are left out.
That's right. So how many negatives do we have total? Count up the total number of negatives.
1, 2, 3, 4, 5, 6. 6.
6. And then let's count up the number of positives.
None.
It's only because they're covered.
Or do we even use them?
Yeah, it's only because they're covered. So before they were covered is
1. So 2, 4, 6.
So +6.
Positive 6 and negative 6.
And -6.
So put those together and it equals 0.
You have made some ionic compounds. Excellent. Does this make sense? So what's the goal when we make ionic compounds?
That we want to have them make sure that they all have partners and that they all equals 0.